Alright, welcome to concurrency. So the idea is concurrent lines are just three or more lines that meet in one point. The point at which they meet is called the point of concurrency. So all of our special segments in the triangle actually have a point of concurrency. We're going to go through that today. So first, the concurrency of a perpendicular bisector. So a perpendicular bisector creates right angles and it cuts the segments in half. And what they meet at is called a circumcenter. So really you just have to know perpendicular bisector meets at circumcenter. The circumcenter is equidistant from the vertices, and if you circumscribe the triangle, meaning draw a circle around, the center of that circle is the circumcenter. So again, perpendicular bisector meets at circumcenter. Angle bisector meets at what is called an incenter. The idea here is if you inscribe a circle, meaning draw a circle inside, the center of the circle is the incenter. It is equidistant to the sides of the triangle because circles are congruent with radii. Concurrency of median. Median is a centroid. So it's called a centroid, and the idea is that it has a 2-to-1 ratio, meaning part of the segment of the median is 2, the other one's length would be 1. The 2 part is 2/3 of the whole thing, when we'll get to that in a minute. Orthocenter is where altitudes meet. There's nothing special about orthocenter, it's just where altitudes meet. So our examples here, the very first one, I see 3 altitudes, so that's called an orthocenter. The second one are perpendicular bisectors because I see 90 and congruent markings, so that's circumcenter. The top right one is 3 medians because all it has is congruent markings, so that is centroid. The bottom right one is 3 angle bisectors, so that is incenter. Midsegments never meet because they cut through the center of the triangle, so all 3 of them do not meet. So these are the 4 that we need to know, and it's all based off of the special segment. If you can figure out the special segment, you should be able to get the segment or the point of concurrency. Now, the one that actually we can do math with is the centroid. It's where 3 medians meet, and this was the 2-to-1 ratio that I was talking about. So I break it down to, is it the 2, the 1, or the 3? The 3 is the whole median. The 2 is the medium part of the median, and the 1 is the small part of the median. So JQ is the 2, because it's the bigger part of the median. JW is the 3, because it's the whole thing. So what I'm going to do is JQ is X, JW is 10.5. I'm going to multiply by the opposite number. JQ is the 2, JW is the 3, so I'm going to multiply JQ by 3 and JW by 2. So I get 3x equals 2 times 10.5, so x equals 7. Divide by 3 and x equals 7. The next one, DL is the 1, JD is the 2. So I'm going to multiply DL by 2 and JD by 1. So 2x equals 6, so x equals 3. NU is the 3, EU is the 1. So I'm going to multiply NU by 1 and EU by 3. So 1x equals 4.85 times 3, so x equals 14.55. That is concurrency. Good luck with the part of the practice.